Welcome back to the third session. I hope you had a tasteful lunch and enriched networking. So for the third session, I would like to call upon Associate Professor Dr. Nargis. Is he here? Yes, to chair this session. Okay, please welcome.
Thank you very much. Good afternoon to everyone. First, let's see. The first speaker of afternoon session is Dr. Hendra from Polytechnic SDT Bandung from Indonesia. I welcome him to come and deliver his talk.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Firstly, let me introduce myself. My name is Hendra. I am lecturer from the Polytechnic STTT Bandung, Indonesia. And first of all, I would like to thanks to the chairman of the Section 11 Malaysia editions, Professor Dr. Azizan Ahmad, and your excellent team for your hospitality, especially during my arrival in Kuala Lumpur last time. And also, I would like to congratulate my supervisor, Professor Dr. Yohei Yamamoto, for successfully launched a very beautiful product and good response from the customer in Japan. So once again, congratulations. So I hope this beautiful product will be available soon in Indonesia and Malaysia too. So once again, congratulations, and I'm waiting this beautiful product will be available in convenience store in Indonesia. So I already got the first one. Maybe I'm the first get this product. Yeah. Okay. Ladies and gentlemen, before I go further to my main presentation, so please allow me to introduce a little bit about my institution. That is the Polytechnic STTT Bandung. So here is the summarize of the history of the textile education in Indonesia. So our journey it started in the 1st April in 1922 when the Dutch government ruled Indonesia at the time. So the Dutch government established the first textile education in Indonesia under the name of the Textile Inrichting Bandung. It was taken from the Dutch language. It's mean textile institution located in Bandung. And then after Indonesia got independence in 1945, the Textile Inrichting Bandung was renamed as the Higher Textile Course in 1954 under control by Indonesian government. And then in 1961, the Higher Textile Course was renamed as a Textile Academy or Academy Textile in Bahasa Indonesia, awarding the Bachelor of Science, offering the 3 years program. So in this time, there are two institutions in the field of the textile in Indonesia. One is focused to the textile education, and another one is focused to research and development for textile. And in 1978, the government decided to merge these two institutions under the name of the Textile Institute of Technology, or ITT, merging the Textile Academy with other institutions. And then in 1981, this institution was separated again into two institutions. One is focused to textile education under the name of the School of Textile Technology, or STTT Bandung. And then another one is focused again to the research and development for textile. And in 2014, the School of Textile Technology transformed into the Polytechnic STTT Bandung. And in 2018, we developed a dual system curriculum which aligned with industrial need and established the first Master Applied program in Indonesia. And in 2022, we just celebrate the 100 years of textile education in Indonesia. Yes, we are a small institute actually, but we believe that we are the oldest and maybe we are the biggest in Southeast Asia in the field of the textile. Here is the map of Indonesia. Everybody already know. So we are the island country, which consists about 17,000 islands, from the smallest to the biggest. And typically we have the 5 big islands, such as the Sumatra and Kalimantan, Sulawesi, Java, and also Irian Jaya. And the Polytechnic STI Bandung was located in Bandung City. It's around 100 kilometers from Jakarta. And I think the Bandung city is quite famous for Malaysian, especially for Selangor people, because I think last week our football team, Persib Bandung, just defeated the Selangor FC with 2-0. I'm so sorry about that. And our typical neighboring country, including the Malaysia and Australia, Philippines, Singapore, PNG, and also Thailand. Ladies and gentlemen, with respect to our research, because we are a textile institute, so we are interested to develop the textile for technical textile and also for functional textile instead of the conventional textile. So here is our research group of interest. So we interested to develop the nanofiber prepared by the electrospinning. Here we fabricate the fiber in nanoscale by using the electrospinning technique. So this application of the product is usually for medical applications, such as in wound dressing, and also filter, mask, etc., etc. And the second one, we are interested to develop the textile-based composite, and we can find out this application of the textile-based composite, such as in the automotive, and also in aerospace. And also, we are interested to develop the textile reinforced concrete for a building application. Here is our latest publication for our group in 2025. So we successfully published 2 papers. So the first paper is development of the textile reinforced composite, and the second paper is development of the textile reinforced concrete. So this paper is successfully published in the international journal indexed by Scopus. So these 2 projects was carried out by undergraduate student under my supervision. And in ongoing research, we received a new member of 5 undergraduate students. And we are focusing to develop a sustainable material from the natural fiber, that's from coir fiber. So in the first stage, we are extracting the fiber from the coconut coir, and then we investigate the mechanical properties of this coir fiber under different conditions, such as for alkali and then acid, etc., to simulate the extreme condition during the application. And then after we extract the fiber, then we convert this fiber into the form of the textile, and then will be used as reinforcement material for concrete, for functional applications such as in lightweight building panel application. Now let's move to the my main presentation with the title Exploring Textile-Based Reinforcement Concrete for Lightweight Structural Application. In my presentation, I always mention about the composite. So what is the meaning of the composite? Here is the schematic illustration of the composite material. So the composite material typically is combination between the 2 material. One we call is the metric material, and the second one is the material reinforcement. And then usually the metric material is in the form of the polymer, metal, or ceramic, while in reinforcement material can be in the form of the fiber, particle, etc., and combined together to form the new material that we call is the composite material, which have the new properties. With respect to the textile reinforcement material, so the composite can be divided into 2. One is the textile reinforced composite, and the second one is the textile reinforced concrete. So what is the difference between these two terms? The difference is only the metric material used. In textile reinforced composite, the metric material used typically in the form of the polymers such as the plastic, ceramic, and metal, while in textile reinforced concrete, the metric used is in the form of the cement metric. And for textile reinforced composite can be used for the automotive and aerospace part or sporting good, while in textile reinforced concrete can be used for wall panel and other light structural material. In conventional concrete, typically a steel reinforced concrete used for several decades, but unfortunately, due to the long-term duration of this steel reinforced concrete, the material or the concrete will be reduced. The strength will be reduced due to the corrosion because interact with the environment such as water or chloride or acid, etc., etc. And then the manufacturing of this steel reinforced concrete also require the thick concrete to cover the corrosion protection. In other side, that it will generate the higher emission because the cement consumption is more. So it is believed that almost 26% emission higher compare we use the textile reinforced concrete. In modern concrete composite, we typically use a textile reinforced material. So the use of the textile reinforced material for concrete, it overcome the limitations of the conventional concrete, such as this is a thin concrete cover and also no corrosion because this is lightweight and durable, also resulting the light and thin and high strength the concrete. So in this work, we utilize the Kevlar fiber as the textile reinforcement material. So the Kevlar fiber known as this is high strength because it's believed that the Kevlar fiber is stronger than steel. This is lightweight, high thermal stability, flame resistant, also a good chemical resistant. Here is the chemical structure of the Kevlar fiber. So we can see here there's a carbon in their backbone. So the Kevlar fiber considered as the organic polymer, and the presence of the carbon oxygen and the nitrogen hydrogen form the hydrogen bond. It's believed that this the reason why the Kevlar fiber is very strong. And then we transform the Kevlar fiber into the three different configurations. So the first one we call is the three-dimensional rebar, and the second one is the 3D hollow integrated fabric, and then the third one is the 3D solid integrated fabric. So what is the difference between these three configuration? So in the first one, that is a 3D rebar. So we just lay down the Kevlar thread in the form of the Kevlar fiber in the form of thread in the one direction. In this case, we lay in the horizontal direction, while in the 3D hollow integrated fabric and 3D solid integrated fabric, so we convert these two, it look like the woven fabric. Here is the woven fabric pattern. So the difference between the hollow and the solid, in the hollow configuration, so the fabric is only in the outer layer only, while in the solid fabric, the fabric is penetrated to inner part of the structure. And then we prepare the cement. Usually we are using the cement mortar, and then we using sand, and then small stone, and then water, and then hardener, and mix together. And then we pour this cement as a metric into the mold like this, and then after 10 days we remove the mold, and then we prepare the samples, and also we prepare the blank concrete. This means that without the fiber. And then after we prepare the samples, then we go for mechanical properties. So there are two kinds of the properties that will be investigate. One is the compressive test, and the second one is the flexural test. The compressive test is typically we prepare the sample in the cubical form in the size of 15 centimeter to 15 centimeter, and then we apply the load. Then the compressive strength considered as when the sample was break under particular maximum load, and then in a flexural test, we prepare the sample with the size 50 centimeter into 15 centimeter, and then we go for a test. We're using a 3-point bending test, and then we apply the load at the center, and then the maximum load required to break this sample we consider as a flexural strength after considering other parameter. And here is the result of the compressive properties. So we can see here is look like there is no strong correlation between the configuration of the fiber with the compressive strength. But we can see from here that in case of the flexural properties, there is strong correlations between the configurations of the fiber with the flexural strength of the composite. Here is the typical common application of the concrete that what we made because the compressive strength is in between 12 megapascal to 14 megapascal. So this product can be used as a lean concrete, a floor-based or non-structural work because the compressive strength is quite low. And we are not recommended this product to use as the column and beam on general building because the compressive strength required is almost double. It's about 25 megapascal. So here is the typical of the lightweight textile reinforced concrete application. So we can use this product for the wall, like a facade panel, and for architectural canopy and lightweight slab and floor panel. So this is the last slide. So thank you very much, and I'm open for discussion. Thank you very much.
Thank you very much for the nice talk. I open the session for any question. Yeah.
Thank you for the very nice talk. And you compare the strengths without fiber and with fiber with a different
Configuration.
configuration. So, but you didn't find any relationship between the strengths and this one. So first, I wonder how much does this structure strong the concrete? And yeah, why you didn't find a difference between how you prepare the structures?
Yeah, thank you very much, Cece, for the question. So as the result that with respect to the compressive properties, there is no strong correlation between the configuration and the compressive strength because I believe that the presence of the fiber in the concrete is responsible only for the flexural properties here. Yeah, we can see the strong correlation between the presence of the fiber in concrete. So, for example, when the blank concrete is measured the flexural, it obtained about a 3.6 megapascal, while when we increase the content of the fibers, so the flexural strength is increased to 12 megapascal. It means that the presence of the fiber is only responsible for the flexural strength only.
Flexure means this bar is has this side.
Yeah, this is the flexural strength.
Okay. And the compressive is
Yeah,
like this.
Yeah.
Okay.
Okay.
So depends on how you give up.
Depend how we apply the load actually.
So for this one, that a fiber has a good effect to the strength of the concrete.
Yeah, when the fiber content inside the concrete is more, so as a result, the flexural strength is also increased.
I see. Okay, thank you.
Thank you very much.
Any more question? Apparently, there is no question. Thank you very much.
Thank you
again.
very much.
So let me I invite the next speaker, Professor Amin Sepehri from National Institute for Material Science, University of Tsukuba in Japan.